do this. All right. A rock with a mass of 0.7 kilograms, we're doing number 2, Biz the Wiz, is sitting at the bottom of a pool of water. If normal force acting on the rock is 2.5 newtons, what is the density of the rock? Okay, so first things first, draw a diagram of the situation and label the forces. So here is my pool of water. Here's my object, my rock. Okay, it has a mass of 0.7 kilograms, so I'm going to go ahead and write that on here. And it has a normal force of 2.5 newtons. Okay, label the forces. So we've got one of the forces labeled, normal force, and then there's two other forces always. And those other forces are always buoyant force and gravity. So that's all you have to do for A. Draw the picture, label the forces, that's it. Put in the numbers that are given. I was given two numbers, 0.7 and 2.5, and I got those in here. All right, set up Newton's second law and use it to find the buoyant force on the rock. So Newton's second law is F net equals ma. So the net force are all the forces added together, which is buoyant up plus normal up plus G down, gravity down. So that would be buoyant plus normal minus, because it's in the opposite direction, gravity equals ma. So that's the setup. So now we put in what numbers we can. We don't know anything about buoyant force. We do know the normal force is 2.5. We don't know what gravity is, but I can find that really easily. Fg is mg, so let's do that real fast. So 0.7 times 9.8. $6.86. And m is 0.7, but a, because it's sitting at rest, is 0. So 0 times anything is 0. So add the 6.86 to the other side, subtract the 2.5 over, and you get the buoyant force to be 4.36. Okay? Easy enough. So then use the buoyant force to solve for the density of the rock. So here are your two buoyant force equations. This is the one you usually use if you are just trying to figure out the number. It's not one we use real often because that requires us to know the mass of the fluid, and we don't usually know that. Okay? But this equation we will use pretty frequently, and it's the density of the fluid, which we will almost always know, times the mass of the object, which we will frequently know, divided by the density of the object, which we will frequently solve for, times gravity. So that's going to be the equation we're going to set up here. So the buoyant force is 4.36 equals the density of the fluid. The fluid is water. Water has a density of 1,000, or 1 times 10 to the third. Mass of the object is 0.7. We don't know what the density of the rock is, so we're just going to write density object, and G is 9.8. So the way I solve this is I multiply everything across the top together. So 9.8 times 1,000 times 0.7 gives me 4.36. Equals, when I multiply those three together, I get 6,860 divided by density of the object. I don't want density of the object in the bottom. I need to get rid of that, so I'm going to multiply that to both sides. So that cancels out over here. So now we've got 4.36 density object equals 6,860. Divide both sides by 4.36. And we get 1,573.4, or that would be 1.57 times 10 to the third if you were doing it in scientific notation. I don't care which way you do it. There you go. All right, and I include the density of water down here, so if you forget it or whatever, that's there at the bottom. I want y'all to try numero 4. Submarine with a mass of 735,000 kilograms sunk to the bottom of the ocean. There's the density for salt water. If the normal force on the submarine is 5,000 newtons, what's the density of the submarine going to be? Okay, draw the diagram, label the forces, set up Newton's second law, find buoyancy, use that to find density. So I will come around and see what questions you have. I'm going to leave my example up here on the screen so you can follow along with it. But try that one problem. Just got to do that one. See if you can figure it before we go here. You've got about 5 minutes. I think you can probably do that. Me with my long-winded explanation.